Well, hello guys, and welcome back to Mr. G Physics. Today we're going to be doing another stream for Newton's law grade 11 and 12. And this time we're going to be working with two objects moving in different directions. I posted yesterday in the description the link that you could get the questions. These are the questions we're going to work, a question in which two blocks are moving. One is moving to the right and the other block is moving down. And then the next one looks a little bit intimidating. It is this one here, but it's not that difficult. So if you managed to open yesterday the link, then you could get the questions. If you couldn't, then you can get it still today. And then it will be helpful to have the question and probably do the calculations at home before you come to the stream. So without taking long, we're going to start with question one. These questions, I took them from the question papers, and I did some changes in there. I did some changes because some part is not applicable, plus because it isn't stream, we are also not going to be repeating the same question, like state Newton's second law of motion in words for both questions. That is not a need, guys. So anyway, without taking too long, let's begin. I'm not going to do a summary today, unless if somebody asks to explain something, because I've been doing the same summary now for the past 3 streams. So it is like going into repetition. I'm going to focus on how do you approach this question, common mistakes learners make when doing these questions, and things that used to be right for marks, but they are not right any longer. So we're going to focus on that one. This first question, say a 6 kilogram blocks or on a horizontal rough surface. Since the moment they say the surface is rough, it means there is friction. So even without reading more, there is friction on the table, okay? Of mass 2 kilogram block is by a block, let me see, rough surface is joined by a 2 kilogram block by a light inelastic string running over frictionless pulley. The frictionless is the pulley, and the pulley, we don't have to use it for anything. Often learners learn or read frictionless pulley, and then they think there's no friction. That is just for the pulley, all right? The frictional force between the 6 kilogram block and the table is 11,76, and I'm going to write it here so I don't have to come back to the question. The frictional force is going to be equal to 11,76 Newton. All right, a downward force of 2 Newton is applied on the 2 kilogram block. And now this is very important. The force is acting on the 2 kilogram blocks downward. It's pulling the whole system down. It is not being acted on the 6 kilogram block. So the applied force is equal to, and I'm writing the data here because I do not want to come back all the time. It's applied on the 2 kilogram block as indicated in the diagram. Mostly that is the data except for the mass. One mass is 2 kilograms. And the other mass is 6 kilograms. All right, remember you can get the questions in the links in the description. I left the question, if I'm not mistaken, I left in the description a link in which you can get the questions, okay? So anyway, that is the situation. You know there is 2 blocks. Somebody's pulling the 2 kilogram blocks down, and then as a result, the 6 kilogram block is moving to the right. Question 1.1 states Newton's second law of motion in work. So it must be stayed in work. Now, previously, this law have 3 main parts. The first part is to say that when a net force acts on an object, the object is going to accelerate in the direction of the net force. That is the first part of the law. Previously, and I'm speaking about last year and before, they did not give mark for that part. It means it was there, is all right. If it wasn't there, it's also all right. But this year, as from 2026, if you do not write that part in the definition, then you will not get full marks. This question is going to be 2 marks. I didn't give marks to this question we're solving because it's not a need at the moment. So that is important. The acceleration, if a net force acts on an object, the object will accelerate in the direction of the first force, or on the direction of the net force. That is the first part of the law, which must be there. The acceleration is directly proportional to the force. That is the second part, must also be there. and the mass of the object, or the acceleration, is inversely proportional to the mass of the object. That is the third part of the law. If you are missing any of the three, guys, you will not get 2 marks out of 2. You will not get 0, but you will not get a full mark. You will be missing marks there. Question 1.2. Now we're speaking about Newton's third law. Identify one action-reaction, and this one is, it brings a lot of mistakes in the exams. Identify one action-reaction pair or force pair acting on the 6 kilogram block. Let's have a look to that one. Let's analyze, and there is an important thing that you need to know. First, action-reaction pair cannot act on the same object, and that one is a common mistake here. So let me show you how to do this one. I was drawing there and writing the data, but let me show you, and this one is for the 8 kilogram block. I will erase it for 8 kilogram block. This one is to determine or to find out the action reaction. So first we have in a table. This one is a table. I'm going to make it like if we zoom it. This one is table. And then on the table, there is going to be the block. All right, so you must imagine that I make the table. Is this table, but I like zoom it. I make it, I enlarge it. All right, so the first action reaction we're going to identify is the reaction to the normal force. Now, what is normal force? Normal force is the force from the surface, which is the table, on the object. So it will be acting on this object pointing up, and I'm going to write here normal force. Now, you must know the definition. This one is force from surface. Surface in this case is the table on object. Now, what is the reaction force to the normal force? Remember, normal force is the force from the surface on the object. Now, what is the reaction? Often mistakes learners make, it says quickly, weight or gravitational force. And no, guys, it's not the weight and the gravitational force. Weight or gravitational force still acting on the block, and is the pulling from the earth on the block. So now here the interaction that we're dealing with is table that is acting or is pushing the block up, and then that block is pushing the table down. So this one here is what we call reaction force. In this case, it's force from block on table. This one can be called apparent weight. These two forces are equal in magnitude and opposite in direction, and that is Newton's third law. In this case here, and I hope you are following me, otherwise you can get confused very easy. This one here, normal, is equal to minus F, I'm going to write for block B, on table, B on T, and I hope, guys, you don't get confused in here. This one is an action-reaction pair. This one is the normal force, is the force from the table on the block, and the reaction to that one is the force from the block on the table. That is the reaction. A common mistake that learners, even some teachers make here, they take the gravitational force as the reaction force for the normal force. Now, let's speak about gravitational force. So let me go to redraw. But now, for this redrawing, I'm going to add few things. I'm going to have the table. Also zoom, because I want you to see the table. The block is there, but this table is, remember, on the earth. So this one is the earth. All right. So now, why do we have to represent the earth? Because of weight. We want to determine which one is the reaction force to the weight or to the gravitational force on the block. So if we have here, and we represent the weight, you all know that weight is straight down. In other words, it's actually straight toward the center of the earth, because weight is the force the earth exerts on objects on or near the surface of the earth. So this is weight. Now, what is weight? In other words, guys, where a weight is the force from the earth on an object, which in this case is the block. That is the weight. Weight is the force from the earth on the block or object which is near the surface. That is weight. So what would be the reaction force? Learners come with a mistake, and even some educators come with a mistake saying, well, that is normal. No. Note the following. The action-reaction pair cannot be on the same object. So normal, if you draw normal, it will be on the same block, and it will not be an action-reaction. So this is the force with which the earth is pulling that block. That block is also pulling the earth up, and that is what we call the reaction. So I'm going to write here, and I'm going to call it here. This one is actually gravitational force. It's a pulling force from this object on the earth, which is, in other words, force from object on block. Those are the action-reaction pair. I gave you 2 action-reaction pair. There are more, but I think with 2 it's fine for now. The 2 is fine for now. This one is Newton's third law. Guys, the stream is not about Newton's third law, but we didn't speak about that one. And I'm sure in many schools, learners are speaking about this. In fact, if you begin with gravitational law, universal gravitational law, this is an important point. So those are, I gave you 2 action-reaction pair for question 1. Identify 1 action-reaction pair. So we also deal with some mistakes. Please don't make those mistakes. So the reaction to weight is the force, the pulling force from the block on an object, or from the block to the earth. And then the other example we spoke about was in terms of the normal force. So that is the reaction to the normal. Guys, if there is any question you can ask before we start now with the actual calculation of Newton's second law, because the next question will be about Newton's second law. Say calculate the magnitude of the acceleration on the 6 kilogram block. So now the acceleration is the same because the blocks are moving together. I just want to leave there in case somebody want to ask a question or clarify something in terms of action-reaction, which is in actual fact Newton's second law and Newton's third law. So saying that, I'm going to clean this one so long so I can explain those calculations, which also some learners find it intimidating and difficult, but it's not so. It is not that difficult or anything like that. It's not that bad. So anyway, I'm going to now clean here so I can start. There was no question. We can start with the other calculation. Now, for this calculation, I always suggest my learners to draw the free body diagram. You need to know in what of the 2 axes you are working so you don't get confused. And note, if the question asks you to draw a free body diagram, which is not the case in here, is the case in the next question, then you cannot add any component. I was looking just on Facebook and I saw some notes of I don't remember exactly, of where they still components. Components are not accepted anymore. So you cannot include components in a free body diagram that they ask you for marks. But this is not the case. So this one is the 6 kilogram block. This is 6 kg. This one is 2 kg. Now, I am going to work simultaneous. If you look there, 6 and 2. I'm going to work simultaneous. I'm going to begin with the 6 kilogram block. I wanted to write actually the like subtitle there, 6 kilogram block, so we know which one are we working with. So 6 kg. We're going to work with that one first. So the first thing is we are going to draw the free body diagram, and do not get confused. This is my free body diagram. It is not for marks. This one is the rough one in which I be able to see what forces are acting there. So here, what forces are acting on the 6 kilogram block? First, you have the tension, which is to the right. The tension is the force that comes to this string, this rope, whatever is the situation. This one is called tension force. You don't have a formula for tension. On the left side, opposite to motion, you have Fk, which is the frictional force. Here down, you have a weight. We already spoke about weight a little bit. This is weight, and then up is a normal force. This one is quite simple. Those are the 4 forces acting in there, in the 6 kilogram block. There's friction, there's tension, there's normal, and there is weight. they ask to calculate the frictional force for this specific object. Now, the acceleration. Acceleration, we are going to calculate it in the x-axis because the object is moving in the x-axis. All right, so the acceleration is going to be on the x-axis, and that is very important because you need to know what forces they are acting on the x-axis. So we're going to start with Newton's second law. F net is equal to ma. We are working for the 6 kilogram block. We are working in the x-axis. If you think you are going to forget, you may write a note saying in x-axis. This one is to organize your work, and that is where we are going to start working now. Net force in the x means what forces are acting on this object in the x. Note also that the direction of motion is going to be taken as positive all the time. So to the right is going to be positive for this specific block in here. All right, so if we go to the x, we have the tension is positive and the frictional force is negative because it's pointing in the opposite direction. So we have the tension. I want to use a black pen. Let me just erase that blue. I want to use the black. So here we have the tension minus kinetic friction is equal to ma. There we go. All right, there is what we have. Now, we do have the friction. We do not have to calculate the friction this time. We don't have tension though, and we do not have the acceleration. So we have two unknown, and it's all right. That is what is going to happen here. So tension, we substitute what we have minus frictional force, which is 11,76, and I promise I will be careful with the calculation at this time. Mass is going to be 6, and then multiplied by the acceleration. Guys, we cannot move on because we have two unknown here. So we're going to stop, and we are going to call this one here equation 1. This one is going to be equation 1. So I'm going to do this just for clarity, and I'm going to write a 1 here. So we cannot go on there. What are we going to do? We're going to repeat the work we did for the 2 kilograms block. So first, I want to write down like the note that I know I'm working with the 2 kilogram block. So I'm coming here and I'm going to write here 4 2 kg. And I'm going to draw the free body diagram first. Now, what forces are acting there? And this one could be tricky. This time, we having an applied force down. Somebody is pulling that block down, and as a result, the whole system is going to move. So first, we have an applied force down here. I'm going to draw it there. This one is applied force. Is that the only one? No. There's also tension. If you come here, tension is being acting up. All right, that is the rope. The tension is acting up. Here is tension. And then there is also weight. So weight is also acting there, pointing down. I'm going to draw it here, and I'm going to write weight. There are 3 forces acting on this object in the y-axis. There are no forces acting in the x-axis. Now, a common mistake, and I said when starting, I'm going to look at common mistakes. I need coffee. A common mistake is learners come and include normal. Is there normal? No, because normal only comes if there is a surface, and that object is not on the surface, but it is hanging from a rope. So there is no normal, and that is the first mistake that learners make when there is object hanging. They include normal force. Note the following. If you have any extra force, you will lose 1 mark. So if the free body diagram is being asked and you include extra forces, you will lose 1 mark. Don't lose that mark, guys. That is not what we want here. We cannot lose marks. So now we are going to work in this object, but if you notice, all the forces acting on the objects are on the y-axis. So we are going to apply Newton's second law in the y-axis. Saying that, we start in here. I'm going to say F net is equal to ma. There we go. Right? Now, what forces are acting there? Well, in this case, we have tension pointing down, pointing up. we have applied force pointing down, and we have weight. Remember, we take in direction of motion as positive. It means down is going to be positive. So applied force is positive, weight is positive, but tension is negative. Okay, so we write that one by net force here. We say applied force, I don't remember if it's given to us. I just didn't write it here. Applied force plus weight is also positive, minus tension, and all that is equal to MA. Remember, you continue substituting up until you reach a point you cannot any longer. So now here, what's the problem? We do not have weight. We do not have weight, but we can calculate weight because weight is a formula that is quite simple. So weight, I'm going to write it on this side. Weight is equal to mg. So this one is what you have to do. You may calculate it here and substitute, or you may substitute the formula here. It's entirely up to you. Just for today, I am going to substitute my black pen is, let me see if this one want to not be so too oh, running out of pen. I have to get a new pen. So now here, applied force, I'm not going to substitute yet, plus weight is mg minus t is equal to ma. There we go. Now I am going to substitute the numerical values. So applied force is 2. Let me show you. There is 2. It's shown in the picture. There is a 2. Plus the mass is also 2. Acceleration due to gravity is 9,8. Minus t is equal to 2a. Now here, we can still go another step. I'm going to move the other little whiteboard of mine here down, and we start adding more numbers there. So now we can calculate. Let's hope I don't make mistake with the calculation. You can do it on your side and then rectify me, please, if I make mistakes. So it's 2 minus, and then it's a product of 2 times 9,8. That will give me negative 17,6. So it's negative. This is negative. It shouldn't be a negative here. Negative 17,6 minus t is equal to 2a. We should not get a negative answer there. Let me make sure the substitutions are all correct. Maybe I didn't make a mistake by the drawing. Let me just look, because I do have the calculations here, and I really don't want to dealing with weird numbers in there. Okay, looking for the values here. Okay, I don't know why I have this one. I substitute the IC. As usual, I make mistake with the calculation because it's a plus. I don't know why I got the negative answer. We shouldn't get a negative answer at all. It is impossible to get the negative answer there. It is 2, and I put minus in my calculator. I deleted 2 plus 2 times 9,8. There we go. Simple calculation. I attempt to make mistake with simple calculations, and this one is 21,6. There we go. There we go, guys. Problem solved. And now here we cannot go any further because we have 2 unknown. So here we stop there, and we're going to call this one equation 2. Now we have 2 equations in here. Let me show you. There we go. We have 2 equations. We have this equation. We have this equation. Now, there are 2 main options to solve it. You can substitute t and then rearrange t and then substitute in the other equation. I personally don't like it. I prefer to do addition. So I add, I'm going to write here add 1 plus 2, and I'm going to show you how I do it. I add everything on the left with everything on the left, and then I add everything on the right with everything on the right. Saying that, what will I write in here? T minus 11,76. That is left side for the first equation. And then I say plus 21,6 minus t, that is the left side of the second equation, and is equal to 6a there, 6a plus 2a. I add everything of the right side. So we are now right here. Let me take that. The light is disturbing there. So that is where we are stopping here. Okay? We are there. Now, what is happening is that the t's let me see, something wrong with them. No. What happened? Are we fine there, guys? I don't know. Seems I lost. Am I still on? Okay, seems I'm still on. I don't know. Something was funny there. Maybe some frame drops or something like that. Okay, let's see. So now we continue. I'm going to continue. It seems like there was a problem with the stream. I don't know what happened, but let's continue. Okay, I don't know what is going on there. Now here, the t's cancel each other. So we have that negative 11,76 plus 21,6, and that will give me 9,84. This one here is 9,84. These cancel each other. It's equal to 6 plus 2 is 8. So the acceleration is equal to that one divided by 8. We get 1,23 meters per second square. That is the acceleration. I'm having some problems here with the stream. I don't know what the problem is. Okay, I hope it's fixed now. Anyway, we calculate the acceleration. The question actually asks to calculate the acceleration, and then the question is asking to calculate the tension. Now, to calculate the tension is easier because we take the acceleration and we substitute in either equation 1 or equation 2. In one of those two equations, we have to substitute the acceleration. I'm going to use equation 1 to calculate 0,8 for the acceleration. For the acceleration, 0,8. Okay, we can always check. We can always backtrack. The problem with the calculation might be in here. Let's check the calculation. Thank you very much. What? It's not that one? I got this value. Let's check the value quickly. Let's recheck. It's not the problem, guys. It's not the problem. Let's recheck. We have in here. So let's backtrack the question. This is what I like. Yes, sir means it's my calculation right, or you say you got a different answer. We can check. That is what we are going to do. Let's check quickly. Okay, F net equal to MA, applied force plus weight is plus minus T is equal to MA. Applied force is 2. The mass is 2. Acceleration due to gravity is 9,8. And the acceleration is 2. So let me redo this calculation. Now I get 2 times 9,8. That is equal to 19,6. So 19,6 I get for this product plus 2. That will give me 21,6. So I got here 21,6. So this is what I get for the equation 2. All right? So if I have now 11 minus, look here, equation 1 is 11,76. Equation 2 is 21,6. So if you go 21,6 minus 11,76, we get 9,84. 9,84 here. All right? Then 6 plus 2a. I'm rechecking the calculation. That will give me 8. And then it's 9,84 divided by 8. That will not give me 0. Give me 1,23. So I got this answer. I got that answer after recalculating. I don't know, check your calculation there. Check your calculation, make sure I got that answer. Now we have to calculate the tension. Now we have to calculate the tension. Now for the tension, I'm going to write equation 1. So equation 1 was T minus 11,76 is equal to 6A. Just let me know if you didn't get the same answer. And then we substitute the acceleration in here. So we have the T minus 11,76 is equal to 6. The acceleration is 1,23. And then you have to do this simple calculation. So T is equal to, and let's calculate step by step, 6 times 1,23 is equal to 7,38. I'm multiplying this one. Then this one is negative, it's going positive to the other side. You add on both sides there. So this one is plus 11,76. And then T is going to be 7,38 plus 11,76. We get that the answer is 19. T is equal to 19,14. I got the same answer. Thank you. Thank you. But thank you for making me going back to calculate this fine. That is the idea of the stream, guys. If you are very quiet there, it seems like it's not helping or you are not working. And I hope you did calculate the questions before or attempt to do the questions. Guys, this one is the calculation of the tension. Now, let me know if you don't understand. If there is something I have to explain again. This one was not that problematic. My mistake is here when I write in the calculator, I wrote a minus here instead of a plus. In the calculator, I went and I transfer a minus. Guys, I have a little bit of dyslexia and sometimes I say something, but I write something else. Yes. So I want to find out if there is any problem, any question, so we can continue in that. We can continue. The next question say, and let me look for it, the rough surface is replaced with a smooth frictionless surface. How will this change affect the answer in question 1.3.1? Down in degrees or remain the same. Guys, the answer is very easy. If you remove the acceleration, the frictional force, how is the acceleration going to be affected? And it's easy. If there is no friction, the net force increases. Remember, and maybe I can show you here for the 6 kilogram block, this specifically, because we calculate the 6 kilogram block. So if we go here back, and let me just show you what I'm saying, and you remove friction, then the resultant force on this 6 kilogram block is actually tension. Only, so it's tension. Then you don't have to subtract any number. Therefore, the acceleration is going to increase. Why is the acceleration increasing? Because the resultant force increases. That's it. When you remove friction, the resultant force increases and then the acceleration increases as well. That is the final part of this question. I hope it's clear and I hope it helped. It's a good question to practice for the test. Remember that they are coming just now, very soon. Like some schools may even start next week with the test or next of next week. So please, if there is no question, we'll moving on to the next question. I'm going to quickly clean the little board so I can draw, and while that, I'll wait for any question that there could be, if there is any. If there is no question, I assume you guys understand everything. There is not much to explain. You're doing very good. So now the next question is a little bit intimidating, but is not necessarily that difficult. Is not necessarily that difficult. Let me see if I can now draw it. We're going to look at this question. And then when you look at that question, you say, oh, my goodness, it is tough, but it's not the case. It's not the case. So here we go. It's not the case. The picture sometimes look intimidating, but in reality, the question is not that difficult. This one is applied force. This one is 8 kilograms. This one is M2. You don't have M2. This one is 30 degrees. And that's it. That is the next question we're solving. As I say, it looks intimidating, but it's not that bad. The question say a block M1, which is the one at the front, with a mass of 8 kilograms, is on an inclined plane with a rough surface as attached with an inextensible string to an unknown hanging mass M2. So we don't know M2. A force of 20 Newton, the applied force is 20 Newton. Let me maybe write it here in my drawing, which I'm going to show you the drawing just now. I just want to write the data. The applied force here is 20 Newton. All right? It's applied to the M1 down the plane as shown in the figure below. Block M1 is hanging down the plane at a constant velocity. So it means there is moving, block M1 is moving at constant velocity, and that change all the things. It make it now very easy. So velocity is constant. And I want you to note the following. Since the moment the objects are moving with constant velocity, the system is at equilibrium, and therefore we apply Newton's first law. So no Newton's second law needed here. The coefficient of kinetic friction acting on the block between X and Y, I remove X and Y from the picture and I forgot to delete it from the question. X was on top and Y was at the bottom. So it's just speak about that triangle that is going like this. That triangle is X and Y. So I remove the values from the pictures and then I leave it in the question. It's 0,2. So the kinetic coefficient of friction in the surface is 0,2. I'm going to also include it here because this means that they are not giving us the friction, they are giving us the kinetic coefficient, and that one is 0,2. Draw the free body diagram for M1. Guys, you cannot include the components in that free body diagram because you will lose mass. So here, let's go. Let me just, I was doing the drawing here. That is the drawing, just for me to analyze. That is not the free body diagram. Now we have to draw the free body diagram. Now, maybe if you think you are going to get confused, you can draw right here the forces acting on the block. Now, on this block, we have the applied force down that can be seen, quite simple. That is the applied force there. We have tension up. There is tension up, and then there's also friction up. I'm going to write it like this. There is friction. So those are the three forces on the horizontal surface. We also have weight, which is straight down. This is weight straight down. And then we have a normal, which is perpendicular to the surface. I'm going to draw it there. That is normal force. Those are all the forces I have to include in my free body diagram. Have in mind that you cannot add any axis or any component or anything, otherwise you will lose mass. So saying that, I'm going to draw here my dot. that dot is the object. And I'm going to transfer all these forces exactly as they are here. The applied force is in this direction. That is the applied force. I have weight straight down. This one is weight. I have friction, this along the same line because they are on the horizontal. Along the same line, I have friction up. And I also have, along the same line, I have tension. So I have tension and friction. Some learners draw it one on top, one at the bottom. It's not the different, guys. You will get marks. This is actually the correct way to do it, but it's fine. You can do it like that. So there is the some forces, and then we only need the normal. Now, if you think you're going to make normal wrong, because many learners draw it straight up, and that is wrong, you lose the marks. Normal is perpendicular, so you can draw it always perpendicular to friction. If friction is here, perpendicular to friction is approximately there. That is normal force. These are the forces acting on that M1, which is the block at the front. Let me show you the picture clear again. Is that block M1. We did draw the free body diagram for that block. Guys, if you do it like this with no extra forces, you make sure you have the head on each vector. If you don't have head, you do not get marks. And there is a lot of learners that don't draw head. Then it's a line, it's not a force. So every force needs a head. And then if you do that, you will get 1, 2, 3, 4, and 5. You will get 1 mark per force. And if you have extra forces that are not supposed to be there, you will lose 1 mark as well. Thank you. So it means if you have the components, you will lose the mark. So this one is the free body diagram as it is here. You cannot include components, no access, nothing whatsoever. This one is question, let me write it there, question 2.1.2. 2.1.2. That is the question. Okay. Now, for the next one, I'm going to redraw a free body diagram because I cannot work on this one. I cannot touch this one. This free body diagram is for marks. It's for marks. If I touch it and I add things in here, values, numerical values or angles or things like that, I'm going to lose marks. So I'm not touching it. I'm going to redraw another one for me to work on. All right, I'm going to draw another one for me to work on. So it's like transfer that one, but to one I can actually do drawing something. So I'm going to redo it real fast. Now, this time I'm going to add the axis. In this case, I'm going to add the axis. Remember, the x-axis have to be with the surface. This one is the x-axis. Then the y-axis is always perpendicular. I hope I draw it perpendicular or is as perpendicular as I can. This one is the y-axis. Now the forces are, I have here friction, which is kinetic friction. I also have the tension. This one is there. I have weight pointing down, and I have the applied force in this direction. The last force I have to still draw is the normal force, which is perpendicular to the surface and is therefore right on the y-axis. This is the same free body diagram, but I can now add the axis and I can break into components, and I need to remember that here is the angle of inclination. This angle here is the angle that you have in the triangle. Those 30 degrees is that angle there at that point. This one is 30 degrees. And it's important because now weight is in none of the axes, and therefore you must break it into components. So you will have a y component in this direction here that is w in y, and if you see is adjacent to the angle, it means it's multiplied by cos of theta. So this one is going to be equal to w multiplied by cos of 30 degrees. If you take this one here, opposite, which is in this case that one there, that will be weight in x, and you can see that is opposite to the angle and is therefore equal to, I have to write it at the bottom here, otherwise it don't fit. W in x, or weight in x, is equal to weight multiplied by sine theta, which is 30 degrees. So this one, I do it in this free body diagram, but I do not touch the other one that is for marks. This one will help me now to know what forces are in X and what forces are in the Y axis. That is for me to work. So now we can go there. We can go there and start doing the calculation. They say calculate the magnitude of the frictional force acting on M1. So M1 is the only one that has friction because M2 is hanging in there. For friction, let's move here. And let's begin by writing the formula for friction. Friction do have a formula. I'm going to write it in here. Friction, kinetic friction is equal to kinetic coefficient of friction multiplied by normal force. I use an N. I saw some learners in other places or educators use Fn. It's entirely up to you. So now here, what we don't have is the normal. And that is exactly why I did draw the free body diagram. Because I need to make sure I know what forces are on the Y. Look here, this is my Y axis. Those, they are the Y axis. What forces we have there? We have the normal and we have the component in the Y axis of weight. Weight is out of the story. I'm saying this one because many learners come here straight and they say normal is equal to weight, mg, and is wrong. That is a common mistake learners make in this topic. All right? So, no. In this case, we're working in the y-axis. Now, in the y-axis, the object is not moving. Object is moving in x. So, in y-axis, the object is, or the forces are at equilibrium. In other words, from here, you have that normal force, which is on top of the y-axis, is equal to the bottom, which is the weight in the y-axis. This one is equal to weight in the y-axis. Now you may do the substitution. Normal is equal to weight is here. I did write it in there. Multiplied by cos of 30 degrees. If you go on substituting, normal is equal to mg multiplied by cos of 30 degrees. And then you can substitute the numerical value now. Normal is equal to mass. The mass, I don't remember, is 8. Is 8 multiplied by 9,8 multiplied by cosine of 30 degrees. And then the rest is calculation for normal, so you can substitute back in that formula there. So let's do the calculation. I hope I don't make mistake this time. With my calculation, is 8 times 9,8 times cos of 30 degrees, and I get 67,896. I don't know. Learners attempt to ask me as well, Newton. This value, I am going to substitute it in that formula. Learners keep asking me all the time how many sizes after the comma. Guys, I mean, really, don't round off to one decimal place. It doesn't matter how many. But the more decimal places I place here, the more accurate the final answer is going to be. So I'm going here. Fk is equal to kinetic coefficient of friction multiplied by normal. I'm rewriting the formula because why not? This is equal to, the kinetic coefficient is 0,2, it's given. And the normal I just calculated here is 67, let me move it here, 67,896. Then I multiply that one, and I hope I don't make mistake. Take your answer, guys. 0,2 times 67,896, that is equal to 13,572. I'm going to round off this final answer to 2 decimal places. So I'll get 13,58 Newton. This one is the frictional force that is acting on that M1. Guys, I hope that is clear for that question. I hope that is clear. That is the calculation of friction in an object that is on the incline. And they ask you for magnitude, so no direction given. Pardon, they calculate the tension in the string. Calculate the tension in the string. All right. So let's see. To calculate the tension in the string, we're going to start with the 8 kilogram block. Why are we starting with the 8 kilogram block? Well, because we don't have M2. We might not even use it. So in this case, we're going to start with the first object. All right, and we are going to apply Newton's first law. Why are we applying Newton's first law? Because the object is moving with constant velocity. If the object moves with constant velocity, that is Newton's first law. All right, so we're going to apply Newton's first law to the x-axis. I'm going to show you now again. So here we go F net is equal to ma. I am going to work in x-axis. So I'm going back to my free body diagram here. And in x-axis, I have the applied force, I have the friction, I have the tension, and I have the component horizontal of the weight. I have 4 forces in the x-axis here. All right, positive is down the slope, negative is up the slope. So what do we have positive here? We have the applied force, we have plus the weight in x, we have negative down friction, which we did calculate previously, and we also have t, which is what we are looking. This one is equal to 0 because the object is moving with constant velocity. So if you want, you can do this to be sure. I don't know, you can always ask your teacher how they prefer. I prefer to write 0 right away here, but you can do that and then say this is 0. It's entirely up to you because the object does not have acceleration as it is moving with constant velocity. Now the rest is substitute what we have. However, we do not have the horizontal component. We can calculate it. So we can calculate this one here. I did write the formula in the previous board. So this one is W in x is equal to mg multiplied by sine of theta because it's opposite to the angle. So this one is, and the mesh was 8, I believe. Looking for it, yes, 8 times 9,8 multiplied by sine of 30 degrees. Let's see how much we get in here. Let's see how much we get in there. We have 8 times 9,8 times sine is opposite in this case. There, so you can see it. Times sine of 30 degrees. This is equal to 39,2. I get 39,2 Newton. Then you have everything. So now you substitute all the values you have in here. So applied force is given to us. I'm going to show you. A force of 20 Newton is applied to M1. That is the applied force. The applied force is 20 Newton positive plus weight is 39,2 minus frictional force we calculated in the previous calculation question is there, 13,58 minus 13,58 minus t. You are looking for t, and this is equal to 0. So the saying that we just rearrange is quite simple here. So you can move t to the other side, is negative. That might be a beta, and you can solve all that. So it's 20 plus, I almost write minus. I want to show, I don't know if you can see that. I almost wrote a minus there. Like I say plus, and then I wrote the minus there. So 20 plus 39,2 minus 13,58, that is equal to 45,62. Guys, I get that t is equal to 45,62 Newton. I hope I got it right, and I don't know, I trust you looking at the question, and maybe you can correct me if I make a mistake. I was about to substitute run in the calculator. That is how we calculate tension for this question. Not all questions are the same. I'm going to leave a link to more materials. If you think these questions are good questions to practice, I have a whole material I release on Newton's law. You can always go and look, and I will leave the link of my link tree in the description below. Guys, any question? We almost done. We only have to calculate the mass of M2. So to calculate the mass of M2, I don't want to clean all this board because there's enough space. So now we have to work for M2. Now M2 is hanging. There are only two forces acting there. That is tension and that is weight. So let's do the free body diagram real fast. I'm going to do this mark here. We're going to work on this corner, and I think it's enough space. Here, forces acting, tension up, weight down. Remember, it is moving with constant velocity. The objects are moving with constant velocity. All right, so in this case, we have that. F net is equal to 0. It's not acceleration. What forces are acting here in the y-axis? T, positive because the object is moving up. So I'm going to do this, up is positive. T minus weight is equal to 0. So T is equal to weight if you rearrange. And weight is mg. So T is equal to mg. We are looking for m. So m is equal to T divided by g. If you substitute, I think I'll have enough space if I compress it a little bit. T is equal to, sorry, not T, M. No, T, M. M is equal to T, which is calculated, and we got 45,62 divided by g, which is 9,8. This is equal to, I have to compress here, I don't want to erase out the whole board. And then we have that 45,62 divided by 9,8 give me the mass, which is 4,66 kilograms. So the mass, I'm going to write it if I can, maybe with another color so you can see it clear because it's compressed, is 4,66 kilograms. Guys, this is the end of the equation. I don't know. I hope it helped. This is Newton's law. I think Newton's law for now is going to be done for streams. If I do stream next Saturday again, we might go to Newton's law of universal gravitation or any other topic that I don't know. I'm thinking of making a stream for the grade 12 on this coming Monday, also 1 hour stream for organic chemistry. I still have to prepare that one. So that is my plan, but I have a lot of work. So I don't know. Guys, I hope it helped. You can now, I'll give you some minutes to ask any question if you have. And it's going to be near 1 hour of the stream. So I don't know if it helped. I hope it helped. You can always give a like to the video. It helps a lot to the channel. And then you can ask questions. You can access the material that is in the description. The questions are in the description. If I'm not mistaken, I can actually quickly look. I think they are in the description. Looking and waiting if there is any question. Yes. Where? Oh, the question I posted in my WhatsApp channel. And in the you go to actually, so they posted on the description, but I see the question I did not post it in the description. I think I posted in post in community. I'm going to look now quickly. I'm going to look quickly. You must always look at the community because that is where I posted. So if I go to community, Yes. Yes, if you go to the community, and that is what I posted from yesterday, if you go to the community or to my WhatsApp channel, then you will be able to get the questions resolved, the same questions, and you can always try it on your own. The questions are there. I maybe will post the link in the description as well, so you can access the questions. But guys, if there is not any question, we'll be finishing in 1 minute. I hope it helped. I hope it helped. It is a lot of work to do streams. It's not so. It's not as easy as it looks. It's not as easy as it looks doing many things and doing it alone. It's also a problem. Like be working with the computer with the software that manage the everything that is going on there. This board, cleaning the board. So it could be difficult, guys. Thank you, Molemo. I'm happy to help you. I'm sure you'll do good in the test. And you always there. Thank you. Must appreciate that you support me. The idea is to help you guys. I don't get any money for this, so it is always to help you. I would like you to be more interactive, like ask questions and things like that. But I don't know, Molemo, did you get the question yesterday? Because I posted in the WhatsApp group and the WhatsApp channel. I did post the link that takes you to this question specifically. I will also post it in the description. And Hassan, I think also Hassan is there, which is really nice. I really appreciate it, guys. Okay, so anyway, guys, I'm going to stop. Thank you for watching. I hope it helped. Go there and try to do the questions. I'll leave the link of those questions. I think I left yesterday. I don't know. Maybe I make a mistake. For sure, it was on the 100% sure it was on the WhatsApp and in the community by YouTube. Thank you, guys. Much love to you all. Enjoy the rest of the weekend. And I think I'll do another stream on Monday for the grade 12 regarding chemistry. And for the grade 11 next weekend, I'll see. Maybe I'll work with universal law of gravitation, but I don't know yet. Thank you very much. Much love to you all. Enjoy your weekend, and I'll see you next time.